Okay, we want to continue with factoring. We're still in section 5.5. We will conclude section 5.5 videos in this third video, and then we'll move into section 5.6. You don't have to write any of this down. This is just introduction to, I'm fixing to give you a note in just a minute. All right, so let's suppose I wanted to factor this problem right here. You don't have to write this down yet. AB minus 6A plus 2B minus 12. Now, what did we say in the last video? What's the first thing we look for? I always look for a GCF. Okay. Is there a number that goes into 1, 6, 2, and 12? You say, well, 2. No, 2 won't go into 1. So there's no number that divides into all four of those other than 1. Okay, is there an A in every one of these terms? No, because there's not an A in these two terms. Is there a B in every one of these terms? No. So if we use just what we did on the first two videos, we would say that this problem has no GCF other than 1. And so then what would we call it? We'd call it prime. Well, it turns out that this problem can be factored. Let me just show you that. If you multiply A plus 2 times B minus 6, this times this, watch what we get. AB, by the FOIL method, minus 6A plus 2B minus 12. So if you FOIL this, you get this. So then, if you factor this, this has to be your answer. So does this problem factor? Yes, there's your answer. But how do you get to that? You can't use greatest common factor. Remember, I told you in this section, we're going to look at about 5 or 6 different techniques in factoring. Greatest common factor is just the first one. So the first thing I will always look for, just like I did in this problem, is I will look for a GCF. But then if it doesn't have a GCF, there are other techniques that come after that that we could possibly use. So what we're going to cover to close out this section is we're going to cover our second technique in factoring. And our second technique in factoring is called factoring by grouping. Factoring by grouping. So you can write this right up here down now. Don't worry with writing this problem because we're going to do this problem in just a minute. Okay, so what I want to do is I want to give you some steps in factoring by grouping. Now, before I give you this, let me just go ahead and kind of get a little bit ahead of myself and let me say this. Factoring by grouping is a technique that in this course, we will only use factoring by grouping when our polynomial contains 4 terms. That's one of the key, when I look at a problem, that is one of the key indicators to try factoring by grouping. But do I still have to check for a GCF first? Yes, that always comes before anything. But look for a GCF first, and then if it has 4 terms, try grouping. So if it has 3 terms in it, am I going to try grouping? No. If it has 2 terms. So if I'm going to look for a GCF and I'm going to try grouping. If it doesn't fall into one of those 2, it's prime. But now we have 2 things that we have to check. Before we do some problems on factoring by grouping, let me give you the steps on factoring by grouping. So I'm going to read out the steps. You write these down and you pause at whatever point you need to pause to get these steps. But it's very important that you memorize or learn these steps. Okay, so to start out a note, title the note, Steps in Factoring by Grouping. Okay, step 1. Group the first 2 terms and the last 2 terms together by underlining them. Group the first 2 terms and the last 2 terms together by underlining them. So, see, the fact that I say that, group the first 2 terms, group the last 2 terms together, how many terms does that make then? It makes a total of 4 terms. Step 2. factor out the GCF from each group, even if it's only a 1. Okay, factor out the GCF from each group, even if it's only a 1. Now, we don't typically factor out the GCF if it's just a 1, but we do in grouping. If 1 is the only GCF, we still factor that 1 out. I'll talk more about that later. Step 3. If there is a common binomial, factoring by grouping will work by factoring out the common binomial. Okay, so if there's a common binomial, factoring by grouping will work by factoring out the common binomial. So what if that binomial, and I'll show you what I mean by that in just a minute. What if there's not a common binomial in the two groups? Then we would call it prime. But the ones that I will give you with 4 terms, and the ones you're going to have on homework, and the ones that you'll have on the final, if I give you one with 4 terms, it's either going to have a GCF or it will be factored by grouping. So I'm not going to give you a whole bunch of problems where it's prime or non-factorable. All right, so let's look at some where factoring by grouping will actually work. And what I want to do is I actually want to start with the very problem that you just wrote down. And that problem is this. So the instructions, factor the following. Write the instructions down. Factor the following. And let's look at this example. AB minus 6A plus 2B minus 12. Now, what does it mean to factor? I want to know what 2 things can I multiply together to get that? Or what 2 or more things? Right now, we're only just finding 2 things. All right, so what's the first thing we do? We look for the GCF in each. Look for a GCF. Well, you've got 1, 2, 3, 4 terms. And you say, wait a minute, I thought we was going to do this by grouping. No, you check for GCF first. Then try grouping. So is there something that will go into every one of these terms evenly? No. There's not an A in every term. There's not a B in every term. 2 won't go into every term because 2 won't go into 1. So there is no GCF for the whole problem. So GCF is out. But we have one other option now to fall back on, and that's grouping. Well, now let's see. Grouping, first of all, it has to have 4 terms. It does. Now, just because it has 4 terms doesn't mean grouping's going to work. You still have to get through the 3 steps. Now, if grouping doesn't work, I'll call it prime. All right, here we go. What's step 1 in grouping? Group the first 2 terms and the last 2 terms together by underlining them. Done. Step 2, factor out the GCF from each group. All right, so I'm going to cover this up. So I've got AB minus 6A. What is the GCF in those 2 terms? A. So I'm going to factor a A out. And when I do, A divides into AB and leaves B, minus A into 6A leaves 6. So this is a B, right? I really should have made that a capital letter or something. This is B minus 6. Plus. Now look at the second group. What's the GCF in the second group? 2B minus 12. 2 goes into both of those. 2 goes into both of those. I'm left with B. 2 into 2B is B minus 2 into 12 is 6. Now, if you cannot complete step 3, it's prime. What does step 3 say do? If there is a common binomial, and this is why we did those problems a while ago. Is there a binomial in this group that also appears in this group? Yes. What is that binomial? B minus 6. So there's a B minus 6 in both of these terms. So since they're the same, we can group. So factor out the b minus 6 times, and if you divide b minus 6 into this, you're left with just a, plus, and if you divide b minus 6 into the second term, you're left with 2. Now, if you get to here and those binomials aren't the same, it's prime. Having said that, when you do these in the homework, more than likely the ones I will give you in the homework, you should have the same binomial both times if you take out the greatest common factor. Now, remember we said our safety net in group factoring is we can always check our answer by multiplying it out. How do we multiply a binomial times a binomial? The FOIL method. So if I do b times a, that's ba, but I'm going to write it ab. B times 2 is plus 2b. Negative 6 times a is negative 6a. And negative 6 times a positive 2 is negative 12. If you will look at this, that is the exact same thing that we started with. Yes, these two terms are in a different order, but the order that that's written in does not matter. It's still the same thing. Okay, so let's do another example now. X cubed plus 5x squared plus 3x plus 15. All right, first, look for a GCF in each group. There's not one. Second, try grouping. Group the first two terms, group the last two terms. Look at the first group. What's the GCF? X3 and an X2. So your GCF is X2. If I take an X2 out, divide X2 into X3, it leaves X, plus X2 into 5x squared is just 5. Plus, now GCF in the next group, 3. 3 into 3x is x, plus 3 into 15 is 5. Now step 3. Do we have a binomial in this term that is also in this term? Yes. What is that binomial? X plus 5. So if I bring out the x plus 5, if you divide that into the first term, you're just left with x squared. Plus, and if you divide x plus 5 into the second term, you're left with 3. So can I multiply two things together to get this? Yes, these two things. So when I say factor this polynomial, this is that polynomial in factored form. All right? Now, before I work, I'm going to do 3 more examples, but before I do that, I want to ask you one quick question first. I want you to complete this statement right here. I did this a while ago. 28 is equal to 7 times blank. Of course, that's 4. Now, suppose I change that 7 to a negative 7. Then does it affect what goes in that blank? Yes, it does. Because if you put 4 here, if you multiply those together, you don't get 28. So this should be negative 4. So how does it change it? Up here, you're dividing 7 into 28, which is 4. But if it's negative, you're dividing negative 7 into 28, which is negative 4. So it makes a difference if what you're dividing by is positive or if you're dividing by negative. You'll see why I said that in this example. Example number 3. xy plus 2y minus 10 minus 5x. Factoring the problem here, factoring the polynomial. First, look for a GCF. Is there a GCF in every term? No. Next, grouping. Group the first two, group the last two. Step 2, factor the GCF from the first group. Well, you don't have an x, you don't have a number, but you do have a y. We'll factor out a y. Y into xy leaves x, plus y into 2y leaves 2. Minus, because this is a minus. Now, what's the GCF in the next group? 10 minus 5x. Well, 5 goes into both of these. Now, this is where you have to be careful. Because right here, when you divide 5 into both of these, don't forget that it's not really 5, it's what? Negative 5. So if you say negative 5 into negative 10, that's a plus 2, not a negative 2. But then if you divide a negative 5 into a negative 5x, that changes to plus x. Now you can always check to make sure you did it right just by doing this in your head. Distribute this in your head. Negative 5 times 2 is negative 10. Negative 5 times x is negative 5x. So if you distribute that in your head, you did that right, then what's in here is right. Now, you said, now wait a minute. X plus 2, these aren't the same. Yes, they are. Remember, addition is commutative. If I say 7 plus 3 or 3 plus 7, is that the same thing? Yes. So x plus 2 and 2 plus x is the same thing. Now, you don't have to rewrite it if you just know that it's the same. If that does bother you, then rewrite it. You don't have to, but if it bothers you, rewrite it. But do we have a common binomial? Yes. So take out the x plus 2. Now divide x plus 2 into this first term, and when I do, I'm left with y. And divide x plus 2 into that second term, I'm left with 5. Is there a way I could check this? Absolutely. If you just FOIL this out, it'll take you right back to where you started. Okay, 2 more examples, and that will close us out on section 5.5, and it will also close us out on grouping. So let's do this one. M squared, n squared, minus 6m squared, minus 2n squared plus 12. All right, first thing I'm going to do is look, and I know that when I look at this problem, I feel confident grouping will work, but I don't want to skip straight to grouping. So look for a GCF in every term. Is there something that goes into all 4 of these? No. There's not an M in every term. There's not an N in every term. 2 won't go into every term because 2 won't go into 1. So there's no GCF in every term. So let's try grouping. Group the first 2 terms, group the last 2 terms. So if I look at the first 2 terms, m squared n squared minus 6m squared. There's no number, but m squared divides into both. So m squared into m squared n squared is n squared, minus m squared into 6m squared leaves 6. Minus, because that's a minus. Now the GCF in the second group is 2. Remember now, you're not dividing by 2, you're dividing by negative 2. So negative 2 times into negative 2n squared would be plus n squared. And negative 2 into a positive 12 is minus 6. Now, do we have a binomial common in both terms? Yes, we do. What is that binomial? N squared minus 6. Now divide that into this first term, and when you do, you're left with m squared minus, and if you divide n squared minus 6 into the second term, you're left with 2. And if you FOIL this out, you can to check it. Okay, last example, example number 5. xy plus 2x minus y minus 2. Step 1, look for a GCF in every term. There's not, so that's out. Now try grouping. Group the first 2 terms, group the last 2 terms. What is the GCF in the first 2 terms? xy plus 2x. Your GCF is x. When I take that out, x into xy leaves y, plus x into 2x leaves 2, minus. Now, let's do the GCF in the next group. Well, when you look at that, you say, well, there's no GCF. That's correct. Look back at your steps that you wrote down a while ago. Remember, step 2 says, factor out the GCF from each group, even if it's only a 1. Well, there is no GCF in this group, but since I'm in grouping, I got to follow the steps. So, is there a GCF here? No, not other than 1, but I still have to factor that out based on the note. So, I'm going to factor out the 1. Now, divide. Negative 1 into negative 1y would be a positive y, and a negative 1 divided into a negative 2 is plus 2. Now, do we have a common binomial in both terms? Yes, we do. Y plus 2. And if you divide y plus 2 into this first term, you're left with x minus, and if you divide y plus 2 into this second term, you're left with just the 1. And I could FOIL that out to check that and make sure that that works. So we have covered 2 techniques in factoring at this point, and that is factoring by looking for a GCF and factoring by grouping. Now, there are still other techniques that we've got to cover because, let me just show you one and then we'll stop the video. Let me show you how this one factors. Just take my word for it. If I multiplied this out, I'd get this. So if you factor this, you get this. Now, does this problem have a GCF? No. Can I do grouping on this problem? No, because it has 3 terms, not 4. So see, this problem factors, but I can't factor by using GCF. And I can't factor by grouping because neither one of those will factor this problem. So what we will do in our next video, and that will take us to section 5.6, is we will begin looking at other factoring processes to factor the other problems that we can't use our previous 2 methods on that we've covered in section 5.5.